Hello, I'm Mr. Callan here to help you with Chapter 15, Lesson 10. Using the Pythagorean Theorem. How do we use this? How do we see it in real life? Whatever the assignment is, pause, take a look now. Come on back when you're ready to go to the back page. And bring some questions to class, ladies and gents. Here we go. Whatever the date and whatever the assignment number, our goal today. Use the Pythagorean Theorem to solve for a missing length. Pause and come on back when you're ready for some notes. And I might encourage you to pause here, kind of draw those pictures, make this big old T chart for comparing and contrasting, and come back when you're ready. All right, so let's take a look at these two problems, all right? So on the left, we have a right triangle with lengths of 3, 11, and some missing number that we'll call B. And on the right, we have another right triangle. Oh, hello, well, there's immediately a similarity. Another right triangle here, we have lengths of 18, 15, and C. So, ladies and gents, we have right triangles for both, and both are missing a particular length, to which we can solve using the Pythagorean theorem. A squared plus b squared equals c squared. Kick it back on to previous days where we talked about, okay, what's the c? That c is the hypotenuse. You could also say that it is the longest edge. I'm going to go ahead and zoom this out a little bit. But if you can't quite tell which is the longest edge, you can know the hypotenuse by identifying the side that is opposite of the right angle. Meanwhile, the two legs are the two edges that form the right angle. You can even say make the L. They are also shorter than the hypotenuse. Now, a lot of similarities, ladies and gents, but I want you to pause for a second and decide what's the biggest difference between the left problem and the right problem. I hope that you were able to identify the fact that on the right, the side that is missing, the length that is missing is the hypotenuse. Meanwhile, on the left, the length that is missing is a leg. So when we would write out the two equations, on the left we have 3 squared plus b squared equals 11 squared, while on the right we have 15 squared plus 18 squared equals c squared. Now, I want you to look at those. Again, what major differences do you see? So on the right problem, 15 and 18, the legs are both known and they're on the same side. So you can use your calculator as an appropriate tool here to add them up. Square 15, square 18, add them up. However, over on the other problem, well, I know 3 times 3 is 9. I don't know what b times b is, so I'll leave it as b squared. I know 11 times 11 is 121, but those are on opposite sides, ladies and gents. Being on opposite sides, in order to put them together, we have to use opposite operations. Positive 9, negative 9 makes 0. Okay, so what does that leave us with? That leaves us with b squared on the left side, 112 on the right. Now, in both cases, folks, we don't have yet a solved number for b. We'd like it to say b equals, but right now it says b squared. We'd like it to say c equals, but right now it says c squared. So actually, I feel another similarity coming on, and that is the inverse operation of a power. The inverse of a power is a root. So to get rid of b squared, we're going to take the square of b from both sides, and the square root and the square power will cancel out, leaving us with b to be about 10 6 centimeters. On the other hand, on the right side, to get rid of a square power, we take a square root, and this leaves us with c equals about 23 4 tenths. Interesting similarity here. Neither of these pieces were perfect, and we had to round both to the nearest tenth. But the most important part, ladies and gents, is understanding that on the left side, we know the hypotenuse. We're missing one of the legs. On the right problem, we don't know the hypotenuse, but we know both of the legs. So every problem on the assignment for the rest of today, ask yourself, is the problem I'm doing more like the problem on the left with the missing leg, or the problem on the right with a missing hypotenuse. And then you can use these examples to help guide your solving. Let's go ahead now and start up some of those homework assignments. We're going to do number 1 and 3 together, and then we'll move to the back side. Firstly, we are asked to write an equation that can be used to answer the question. Then we are asked to solve. And finally, it does tell us round to the nearest tenth if necessary. I'd kind of like nearest hundredth, but that's okay. All right, so take a look at number 1. I'll do this as a think aloud. I'll say everything aloud that I'm thinking in my head. So how far is the ship is the question from the lighthouse. And if I see a right triangle, I immediately write the Pythagorean theorem down. A squared plus b squared is c squared. And in this case, ladies and gents, we don't know what the hypotenuse is. So I'm going to write d. You can leave it as c. You can write x if you want. Meanwhile, the two legs would be 6 and 8. And so I'm thinking back, okay, well, these appear to be on the same side, so let's square them. 6 squared is 36, 8 squared is 64. Put them together, and you get 100. Oh, I got to pause. I keep forgetting this is one habit I'm trying to build. Always make an estimate about how much I think it is. And if one's 8 and one's 6, I'm guessing the other is 9, maybe 11. Let's find out. All right, so d times d, some number times itself is 100, and I bet you already know to get rid of a square power, we take the square root. After all, square powers and square roots cancel out, which leaves us with d equals, oh, now I know there's possibility of having two numbers here. A negative times a negative is a positive times a, but you really don't have to worry about negative lengths. That's not really a sensible answer to have a negative length. So in this case, it's precisely and exactly 10 miles, which is awfully close to my estimates of 9 and 11. Pause, rewind if you need to. Otherwise, let's go on to number 3. Again, make sure you're asking yourself, how are number 1 and number 3 similar? How are they different? Well, they're similar because they're right triangles. Oh, and Mr. Callan's going to make a quick estimate. So we got 100, we got 80. This appears to be smaller than both. I don't know. What do we think? 60? 40? Let's find out. In this case, do we know the, oh, yes, we do. We know the hypotenuse. We know the longest edge is going to be 100. One of the things that is missing is one of the legs. So p squared plus 80 squared is 100, and perhaps that's the most important part. Then if you want, you can go back to your notes and say, is this more like the problem on the left or the problem on the right? In this case, it appears to be, well, 80 squared I know is 6,400. 100 squared is 10,000. But we would like to solve, ladies and gents. We want to know what p is by itself. So we're going to have to get rid of the square power, the 6,400. Which should we get rid of first? Well, let's save the variable term for later, and let's get rid of this 6,400. The inverse of adding, of course, is to subtract. So a positive 6,400, negative 6,400 leaves us with only p squared. Meanwhile, 10,000 minus 6,400 is 3,600. Let's take the square root of both sides, where a square power and a square root will cancel out, leaving us with exactly 60 yards. And wow, how about that? Look at that. My estimate was close. Not only close, it was quite good. Now, I'd like to tell you that every answer in the world is going to be a lovely whole number, but it's not. Just because we have 10 miles and 60 yards doesn't mean they're not going to be decimals. So expect those in the future. If you wish, you can pause, go do number 2, and just ask yourself, is number 2 more like number 1 or number 3? Yes, folks, you may use a calculator. Pause, come on back when you're ready to move on. So you can continue with the rest of the front page where the pictures are given, but go ahead and flip to the back page. The pictures here are not given, ladies and gents. And I notice in the directions it says first, draw a model, then answer the question, and again, round to the nearest tenth if necessary. So number 9 is about a recreational event or a tool, I guess you could say. Pool table is 8 feet long, 4 feet wide. How far is it from one corner pocket to the diagonally opposite corner pocket? I got to tell you, I'm picturing a pool table, and we want to find out how far it is from one to the other pocket. And any pool table I know is a rectangle, and rectangles, ladies and gents, have right angles to them. So I am seeing two right triangles, but let's just focus on one of them. 8 feet is what? 8 feet is the length. 4 feet is what? 4 feet is the width. How far? One corner to the diagonally opposite corner. All right, I'm going to put 8 and 4. Naturally, 8 would be the longer edge length, 4 would be the shorter. And from here, we ask ourselves, all right, x84, x84, which of those is the hypotenuse? Well, if this is the right angle, the hypotenuse is actually the missing piece. We know the two legs, and I'm going to trust you to go ahead now. If you'd like, pause it, solve for whatever is missing, and then write a sentence. Yes, ladies and gents, we can write a sentence. Pause, come on back when you're ready. All right, I'm counting on you to go ahead and solve this. Make sure you write that sentence in with it if you can squeeze it in. And let's go on to number 11, ladies and gents. Again, find out how these problems are similar, find out how these problems are different. Number 11, a ladder is 17 feet long and it's leaning against a wall. The top of the ladder reaches up 15 feet from the base of the wall. How far is the bottom of the ladder from the base of the wall? Now pause if you want. Go ahead and make your own drawing and come on back when you are ready. So the first thing I'm going to do is draw a ladder. And of course, if this building, if this wall is built correctly, it's built at a right angle or perpendicular to the ground. Meanwhile, what information does this give us? Ladder, 17 feet long, leaning against a wall. Top of the ladder reaches up 15 feet from base. How far? Bottom of the ladder from base. Now, some of you immediately put that X in there. Others of you like to put the numbers in first. Hey, it says the ladder is 17 feet. So write that 17 feet in there. It says the top of the ladder reaches up 15. And if you know the 17 and you know the 15, then you got to ask yourself, okay, I guess what's the missing? Oh, well, that X, the distance along the base, between the base of the ladder and the wall. And so now we go ahead and we try to set it up. But honestly, I think our reading skills and the ability to picture this out is perhaps the most important part. Because now you can see that if the wall is 90 degrees from the ground, and opposite of that right angle is the 17, we actually know the hypotenuse. It is 17. Meanwhile, the X and the 15 are the two legs. And now you're asking, okay, what kind of problem is this? I've solved problems like this before. Go ahead, pause the video, solve it. Come on back when you are ready. All right, whatever it is, ladies and gents, make sure that you write this both in rounded to the nearest tenth if necessary, and write it as a sentence. So that's what I got, folks. Every time you do one of these problems, just ask yourself, is it more like number 1? Is it more like number 3? Is it like number 9? Is it like number 11? Go back to your notes. How are the problems similar? How are they different? Take this, use the Pythagorean theorem well, bring some questions if you have any to class, and let's grow. See ya.